A drill rig in the Sacramento Basin of California is a common sight. Drilling for natural gas has been going on here since the early 1900s. But this well, named Citizen Green, is being used for research that could help California and other western states reduce emissions from carbon dioxide, or CO2, to mitigate climate change.
We're doing a project with an organized collaboration called Westcarb. That's the West Coast Regional Carbon Sequestration Partnership, funded by the Department of Energy, the California Energy Commission, and industry partners. We're investigating the deep geology where we might be able to store carbon dioxide. If we could capture the carbon dioxide that goes up the stacks of power plants, we could bury it deep underground.
The Westcarb research team is investigating Citizen Green in order to understand how the rock formations in that area can store CO2 permanently. The reason we picked the Citizen Green site is because those rock formations have stored natural gas for quite a long time.
Natural gas has been trapped below us for 70 million years in the Cretaceous formation. It hasn't leaked out, and the reason it hasn't leaked out is because it has a thick layer of shale over the top of the sandstone that traps the gas.
The Citizen Green well was drilled to a depth of nearly 7,000 feet. The target rocks for storing CO2 are porous sandstones, 3/4 of a mile or more below the freshwater zone. Thick layers of non-porous shale act as barriers, or seals. Parts of the well are drilled with a special bit, shaped like a donut, which preserves a continuous sample of the rock layers, called a core, which is pulled back to the surface. After the well is drilled, measuring instruments are lowered into the borehole to take readings directly from the rocks.
This is a very sophisticated well. We're taking a lot of scientific measurements that you don't normally take in a conventional oil and gas well. In this particular instance, we're going to find out more about the Sacramento Basin than probably any other well has ever told us.
At Lawrence Berkeley National Lab, scientists test the rock cores to determine how the CO2 travels in the pores of the rock, where it gets stuck between rock grains, and how it can form new minerals. These are some of the ways that CO2 becomes permanently stored.
I'm going to put a drop of water on the sandstone of the storage reservoir rock just to show you how the CO2, which behaves like a liquid, will soak into this formation. The pores in that sandstone provide the storage space for the CO2. In contrast, when we put the water droplet on the shale sample, which is the sealing formation above the reservoir, we see that that fluid doesn't soak in, it just sits there, showing that the CO2 will not penetrate that shale cap rock and leak out of the reservoir. The experiments that we're running on the Citizen Green samples will take about a year to complete, and once we have that data, we'll be able to use it to design large-scale or commercial-scale CO2 storage projects and provide California with a new tool to reduce its greenhouse gas emissions.
We are on the cutting edge of research through the Westcarb program that examines possible ways of sequestering as well as capturing CO2, which is derived from any use of fossil fuels in energy production. As California's greenhouse gas laws become more and more stringent, it's been our feeling that eventually California power plants utilizing the cleanest burning fossil fuel, natural gas, nonetheless will have to start thinking about the ability to store in some safe way the CO2.
Westcarb's research at the Citizen Green site will help the region's CO2 emitters assess geological storage options for meeting greenhouse gas reductions, as well as helping natural gas producers determine how CO2 storage may extend the useful life of natural gas fields. Innovations of this type will help western states prosper while meeting environmental challenges.